how we get data. It's always nice to know where does one even bother getting this stuff from. So we're going to start with there's sort of two main umbrellas this falls under: sampling design and experimental design, as far as how one gets the data and what the data actually represents. So under sampling design, let's talk about that. How do we gather it? Well, we could do surveys and we could ask people. We could ask them their opinion on things. We could call them up on the phone or online opinion polls or surveys. I could sit down with someone and I can ask them a series of questions. I can go back through older data and do studies. This can be observational, meaning I don't even talk to anyone, I just look at what information's out there. Retrospective, meaning looking back at the past, why do you think this might have happened? Prospective is looking ahead to the future, why do you think this might, what do you think will happen as a result of something? Okay, so just kind of refresh ourselves. Population is the entire group of individuals we want information about. A census is when we do a complete count of everything. I guess the question is, if we're interested in knowing what everyone wants, why don't we just ask them? And there's a lot of good reasons why a census is not very practical. Interesting enough, the United States does this once every 10 years. And it used to be, when they first did it, that you would get data about what happened 10 years ago pretty much about the same time that they were doing the current census. So back in the 1800s, it'd be 1880, and they would just release the summary statistics on the 1870s, and you'd go, okay, so things have improved or gotten worse since then. Um, Nowadays, it still takes a couple of years to do that. They've kind of changed some of the process up, but it's not as I guess what I'm trying to say is it's not as practical as it used to be. One concern is it's not accurate. Sort of an interesting thought experiment. Let's assume everyone in the country didn't move just for as long as it took to do the census in the United States. We just kind of put a moving embargo and said you can't move houses. That's not very realistic. You might move from Houston out to Conroe. You might move from Houston to another state. What if they haven't gotten to that part to do the census yet? Okay, so it's not accurate. They might miss information or have people look in all the time. Um, Even with the U.S. Census nowadays, it still takes a couple of years to compile the data, and so they'll announce that a couple months ago we just now finished what happened 3 years ago, and so now we know how it's kind of how unemployment rates and things like that work. It's very expensive to hire people just to go ask questions of how old are you and where do you live? I mean, that's very expensive to do a census. Sometimes it's not even possible. Like I was trying to describe with the people moving. Suppose we want to know the average weight of the white-tailed deer population. How are you going to do that? We got to find them all. If we could find them all, we wouldn't have hunting season now, would we? Oh, destructive sampling is another good one. In order to test how well a light bulb works, you have to do stuff to it. And if I want to make sure that the design is correct, what am I going to destroy them all? Um, anyway, so just safety ratings for cars. No, we can't destroy all the cars just to see how well they keep up in an accident. Which then brings up samples. So we're going to have to actually look at a smaller subset of the population and look at what the sample can tell us. And then we take the sample to generalize to the population. Well, the way we collect the data is called sampling design. And so we're going to look at several different methods on doing sample design. Starting with an idea of sampling frame. A sampling frame is a list of every individual in the population. Again, you got to know this. We're looking, in order to do a proper sampling frame, I have to know everybody in the population. I have to be able to write them down on a piece of paper, or not a piece of paper, but write them the entire list down somewhere, have the list down somewhere so I can randomly pick people. Okay, first type of sample design is called a simple random sample, or SRS for shorthand, and that's pretty much what you'll hear it called the rest of class as SRS. This is when we can randomly pick individuals in such a way that every individual has an equal chance of being selected. For example, if I was going to look at 100 high school students, I could put their names in a hat. So writing down their name on a piece of paper and then cutting up the piece of paper. When I wrote it on the piece of paper, that was a sample frame, and then I could put their names in a hat, and then I have each student has an equal chance of being selected. Within that, sort of in a similar type fashion, if I say that every set of individuals can be selected, then if every person can be selected, then every group of individuals can also be selected as well. Okay, so we call that a simple random sample. Okay, next up is a stratified random sample. Stratified is when I'm going to read it, the technical term, and then we'll go back and clarify this. So it's a population divided up into homogeneous groups, or called strata. Homogeneous simply means there are similar characteristics within each of the groups. So say for example I want to collect information about our class. I could group everyone by gender, so I could put all the boys on one side, all the girls on the other, and then I could ask them a question. Well, that would be homogeneous, would be the gender. Okay, and then once we've picked divided up the group, within the group we then do an SRS of each stratum. So going back to the high school example, if I group students up by grade level, and then I can randomly pick seniors and randomly pick juniors, and then ask them whatever it is I want to ask them. Okay, systematic. Another method. Systematic is select sample by following a systematic approach. So that makes a lot of sense. Okay, so what we do is we randomly select where to begin, and then we add a consistent number on top of that. So I'll kind of go through this example in a second, but in a systematic sample, I randomly pick where to start. So every fifth person, and I'm going to add 10 on top of that. So start at 5, and then 5 plus 10 is 15, and then 15, then 25, and then 35. So I just talk to that particular person at those intervals. Okay. Yeah, so it's sort of saying the same thing, that if I know I have got 2,000 students and I want to have a sample size of 100, then I want to make sure I have at least 20 people in the sample. So I randomly pick a number and then I add 20 to that. And then that'll tell me, give me a representation of the population. Okay, cluster is another type. Cluster is based on location. This is where I break a population up into various regions, and I randomly pick a region. And when I randomly pick the region, I then sample everybody there. So in a classroom setting, I could pick everybody's second period, and I could talk to everybody in that particular classroom. Would be one way to do that. Another way to do it, sort of for political survey purposes, I could randomly pick a county, and then I could interview everybody in the county in Texas, or a zip code or area code or something like that. And then we have something called a multi-stage sample. Multi-stage is when I select, when I break a group within a group, and then I've got a continually smaller process along the way. So for example, if I want to check and see how well ice cream is being manufactured, I would randomly pick a day, and then I would randomly pick on that day, I would go look at the ice cream that was made on that day. I would randomly pick a flavor. I would randomly pick a box that was produced during that day, and then inside that box I would then randomly pick two of the package. So the fact that I did multi-stage, I did random picks on given stages, that's what makes it multi. SRS is used at each stage. Alright, so let me go through advantages and disadvantages of this. SRS are unbiased, they're easy to do. Disadvantage is a large variance, so there could be a lot of variety in the types of data that we collect. Random, it might not be representative. Of course, none of this might be, but just have to understand that if I randomly pick it, it might not all represent the population that well. And again, we'll talk about more about that. And in order to do this, I must have a sampling frame, or a list of population. Okay, stratified. Advantages, it's actually more precise than an SRS. Anytime I can separate out the population somehow, I get a little bit better picture about what the population's thinking. Less variability in the data, and if I pick a strata that already exists like gender or race, sometimes it's a little bit easier to group people like that, and then I can pick my random sample. It's difficult if I have to find a way to divide the stratum first. And the formulas for working the math out on this can be a little on the complicated side. And again, it needs a sampling frame, so it goes back to that. I need that list of the entire population to properly do this. All right, systematic random sample. Advantages is I don't need a sampling frame for this one. It's real easy to pick a starting position and then just add 10 or add 20 to it. It does give me a better likelihood of getting spread out in the entire population, so I typically get a better sense as to what the whole population is thinking. Sometimes it's cheaper, more efficient and cheaper. Disadvantages, it does allow for a lot of variety in the types of data. Can be confounded, some sort of pattern that maybe I just don't see yet. Confounded simply means there are other factors affecting the data that I have not, I'm not able to separate for. And the formulas can be a little on the tedious side for this. Okay, cluster advantages, unbiased. It's real easy to pick a location. Everybody's already there. And I might not even need a sampling frame, especially if I'm just picking a general region that I'm going to sample. But again, disadvantages, it might not be representative of the population. And again, the formulas can be complicated. So let's go through a couple of practice problems here. Identify the sample design method. Educational Testing Service needed a sample of colleges. They first divided the colleges into small groups of small, public, private, then randomly selected 3 colleges from each group. That would be stratified. County commissioner wants to survey people in her district to determine their opinions. She randomly selects blocks and then surveys all who live there. That's cluster. Local restaurant wants to survey customers about their service they receive. They randomly chooses a number between 1 and 10, and then he goes to every 10th customer after that position. That would be systematic.